So let's dive into each one of these. And I mentioned shielding integrity. I put it first um, because coaxial cable, as much as I love coaxial cable, it is inherently fragile. Um, our manufacturing community has done a great job of improving the quality and the performance of coaxial cables, whether they be drop cables or hardline cables. But the reality is that our systems, the modern cable television networks, are required to be closed systems. That's what allows, and Ron has referred to this a lot, the frequency reuse relationship between over-the-air broadcasters as governed by the FCC and cable television operators. We both use a lot of the same portions of the spectrum, and increasingly so. So it's important that cable television systems are closed systems, and they're closed because the coaxial cable has this thing called shielding integrity or shielding effectiveness. And it's really defined as the amount of energy or the level difference in dB between the RF energy coupled with and without the shield in place. So if you have a conductor that's shielded, it can withstand a significant amount of RF energy, and we'll look at what that level is in some very specific instances.
And that RF energy being over-the-air energy that could leak into the plant. Likewise, the plant could leak out if that shielding integrity is compromised.
But a lot of us that have been around for a long time just sort of think of all of it as SNR, as the generic or general industry term for signal quality. But SNR is measured very differently than CNR or MER or RXMER. But when we look at our intelligence tools, we can see that there is an impairment that's resulting in poor signal quality, whatever you want to call it, SNR, MER, RXMER. Okay. And the likely cause is that there's some unintended carrier that's under your carrier that's resulting in that. But the cause is typically a shielding defect somewhere. It's just a matter of how you categorize and localize the symptoms of low MER, SNR, CNR, whatever you want to call it, to say where is the cause. And in most cases, you're going to find that you have a shielding integrity problem.
So back to our first pillar is the cause of the degradation that we're seeing in our MER, our SNR, or even CNR. Multiple acronyms, back to one pillar.
Right. And this one is actually CINR. In Comcast, we have this thing we call Center, and the illustration in the top right of the screen shows several SEQuam carriers with their relative receive power and also their SNR. It's actually not SNR, it's RXMER, but we illustrate it as SNR. And you can see those two channels at 597 megahertz and 603 megahertz center frequency have low SNR, even though their receive power is approximately the same as the channels adjacent to them. So it tells you that there's not a frequency specific suck out that's resulting in low receive power and low SNR. There's actually a carrier or energy underneath of the carrier that's degrading the SNR or the RXMER for those two channels. So that's a symptom of ingress that's resulting in poor receive MER for that device. But to your point, some of the symptoms that we'll measure could be CNR, SNR, MER, CINR. We could also see FEC, or we'll talk more about that one, I'm sure. Forward error correction, whether it be correctable or failed FEC. It may show up as FM ingress because FM is still very prevalent everywhere, or high bit error rates. So those are some symptoms of shielding integrity defects. Now, I wanted to just give people some hope here, right? Because the hardline cables that we use, we've tested them in our laboratories for their shielding effectiveness in a chamber called a GTEM in our Comcast laboratory, and that top left graph there says shielding effectiveness of hardline in a cable and connector. So when properly installed and the physical and structural and electrical integrity of the cable is not affected, the shielding effectiveness of hardline cable is actually extraordinary. It can withstand, over 100, between 120 and 150 dB of over-the-air signal from intruding into the cable, which is pretty extraordinary. Now, that's when it's properly installed.
And that's a nice flat line out past the gigahertz. Out to, do you measure out to 1.2 gig there, or just out to 1 gig? Nice and flat.
This is an older screen or an older test, so we only went out to 1.2, or I think 1 gigahertz on this particular test.
Yeah.
So 1,000 megahertz.
That's still great performance.
Yeah, it's still pretty darn good. The one in the middle is actually some cables that have been stressed. So you think about your drop cable, particularly in an aerial installation that's connected from the house to the pole, and the wind and the birds and the squirrels and the snow, and all of those things cause that cable to flex over time. So we do flex our cables like 10,000 times in a machine that stresses the cables and tries to simulate the deterioration of that braided shield in Series 6 drop cables over time. And so what you see is, over time, as the drop itself flexes and moves and bends, that shield breaks down, and you'll start to see a degradation in the shielding effectiveness of that drop cable. So we may see a piece of drop cable that looks perfectly good, our RF levels are fine, but that we have low signal quality. And it could just be because the shielding effectiveness of that flexible cable has broke down over time because of the environmentals. So when in doubt, replace the drop. The one on the right, now this is really interesting because we took that same piece of hardline cable with a properly installed hardline connector, and we started to loosen that hardline connector. And most all of the hardline connectors I see have 6 flat spots on there, 6 flat sides for the purpose of tightening. And so if you think about the circular nature of that, each one of those flat spots is about 60 degrees of rotation. So we took a perfectly tight hardline connector and loosened it 60 degrees at a time, or one flat spot at a time, and measured the shielding effectiveness of that particular connector. So you can see it went from better than 120 dB of shielding effectiveness all the way down to about 60 dB of shielding effectiveness through one rotation. That's one 360 degree rotation of a hardline connector. So
one twist and you cut your isolation in half, basically. Yes. So yeah, that's not so good.
No, it's not.
Tightness counts.
Keep your connectors tight. And I tell this story all the time because we all know Ron Rannick's a genius, and I've been reading his material for years and years. He's taught me an awful lot, whether he knows it or not. And the very first time I met him was because I wanted his autograph, and I still have it. But I asked him to sign my copy of the Telecommunications magazine, and he signed it, "Keep your F connectors tight, Ron Rannick." and I was expecting something really, really wise and amazing to come out of his mouth, and he wrote, "Keep your F connectors tight." Now, I'm embarrassed to say initially I was disappointed by that, but the more I thought about it, the wiser it got.
It was wise.
Oh, he's so right.